Start. All right, guys. Hi. I hope you enjoyed the last session. What I'm going to do in this session that is to start with the basic lab setup for the Python, labs that are going to do in the next couple of weeks. So before we start, any questions regarding what is Python and what are the tools that you might be familiar with before? Let me just give you like 5 minutes before we start. Any follow-up from last week? Right. Let me do first something. Let me just explain to you how the lab would look like. What are the tools we're going to use for building the lab? Now, this is a common practice in the IT environment that when you set up the lab, you don't just set up on your machine so that every time you do any changes, you write a code that is only available to your machine. We prefer a technique, what we call DevOps, okay, where a developer or a person who develop the code and also simultaneously operate the code, right? And we'll talk about this along this next couple of weeks, how DevOps actually works. So what we're going to do today, the first session of this discussion is to set up what we call a CI/CD pipeline, okay? CI/CD stands for continuous integration and continuous deployment. So there will be an online version of your code, right? So when you write any code, you change anything, that would also reflect online. There's a cloud service which is free for us, which is going to be GitHub for these presentations. The benefit is, if you want to share your code with somebody, maybe your interviewer or maybe your colleagues, right? Now, sending a code as a text file sometimes is very difficult because sometimes the email system prevents to attach any code file because they think this is a virus maybe. So it's always beneficial, always recommended that you use an online platform to do that, and it's going to be GitHub. So in our case, let me first draw a typical schematic diagram. What are the tools we're going to use today and how they're going to be linked. So firstly, let's say this is your computer, okay? Let me just name this. So this is your, am I not? Oh, I'm sorry. Really sorry. Okay, just give me 1 sec. I think I should be presenting now. Yeah, right. So let me first give you the schematic diagram of the development environment. So the first thing is your PC or your computer. I just put computer. This is where you write your code, okay? And then we have another part of another replica of the code. Let me just use a different color for this. And this is going to be the online version of it, okay? And this is GitHub. GitHub is what we call a version control system, VCS, where you put your latest version of code. Now there are many other usage of GitHub or the version control systems. One is, let's say you write a code and then you realize the code is not correct. The modification you made was not correct. So you might need to roll back to the previous version, right? Now, if you maintain a single text file, it's very difficult to do that. So things are very easy when you do with GitHub or any version control system. Now there are many other version control systems, but GitHub is kind of an industry standard. So I believe if you are learning it, learn the industry standards. When you put that on your CV, for example, when you share your CV with your potential employer, you might put a unique URL that represents your profile, and you have all your files there, all your codes there, right? So what happens in your computer? You first install something called an IDE. So an IDE is an integrated development environment, okay? So let me just name this here, IDE. IDE is a tool where it lets you write the code, Okay. Now you might say, I can write the code in Notepad. Yes, you can. But the problem is when you deal with complex projects, when a lot of thing gets involved with your code, then a simple textual or text editor is not enough, right? In that case, you might go for something better. And this is what an IDE is. So essentially what happens, the IDE contains your code and some other files, and the IDE resides in your computer. Now the IDE is just an editor. It cannot kind of compile your code. What do I mean by that? So if you follow me in the last presentation last week, a programming language is just like any other language where we use to express our intent to a computer, right? So let's say I want to do something with the computer. How do I tell it to the computer? This is where the programming language comes in. So every programming language has their own semantics, own structures, syntaxes. Now based on those syntaxes and semantics, we write the code. And then somebody needs to take that code and compiles into the computer's language, which is binary. Now we can't speak binary. It is very difficult to express your things, your intent with a binary language. So we need somebody to actually take the code which we understand and compile it or translate it to what a machine understands, right? That is a part what we call compilation. Okay, so the IDE is where you write your code, but to tell your machine what to do is where the compiler comes in. So we need another tool which is called a compiler. Let me just change the font.
So 1 second. So you're saying the IDE is where we write the code?
Yes.
The compiler is?
That compiles the code and translates that to the machine's language.
Okay. So wherever we write in the IDE will be understood by the compiler. So the compiler is like the translator.
Exactly. So if you only have the IDE, you cannot compile the code because you don't have the compiler. It will tell you that, okay, you write the code here, but I don't know how to compile it. I don't know how to translate that. So for that, you must have a compiler and an IDE. Now, the development process of the contemporary development process is very much different than what we used to have like 5-10 years back. Here we have a situation where when you write a program, there is one more term I need you to know, is called library. Okay, library, or sometimes called packages. Now what are they? For example, you must have seen a lot of people are doing machine learning kind of applications development. Now do you think that anybody who creates a machine learning program needs to do all the maths to do the program? Of course not, right? That's the whole point of having this new generation programming, that somebody has done those things for you, and your job is to kind of leverage the existing codes and use them in your code. Okay, so libraries are those kind of interfaces through which you can use someone else's code. So you kind of save your time of by not doing the mundane jobs of writing everything from scratch. So the problem is, sometimes when you develop multiple projects in your system, each project requires different versions of libraries. Okay, so for that, if you install everything, all the libraries in your system directly, it might collide with some other projects. Let me give you an example. Let's say you are doing a machine learning application. We'll see how to do that, but in a generic sense, first of all, machine learning application would need certain libraries to write the code. Now the problem is, the version that you're using to write the code may be an older version. Maybe someone else wrote that code for you and you are extending that code. Additionally, you are doing another project where you need some newer version of the same library. Now, the native nature of an operating system or a compiler is, the moment it sees a newer version is coming, it kind of replaces the old version. Now, the moment you do that, what will happen? That other project that used the older version of the library would not work. Am I clear on this case? So the necessity of having different libraries together, different versions of libraries together. So for that, people realize, is it not better to isolate these collections of libraries for individual projects? So if I'm doing a project, I need these libraries. So I can isolate those collections for this project only. If I use a different project, I might use a different collection of libraries. So on that context, a new term that came up, which is called a virtual environment. A virtual environment is a collection of libraries which is kind of associated with individual projects. Okay, so I'm giving all the generic terms now, and then I will give the actual packages that we're gonna use for this development. So here we add one more term, which let's say put a different color here, and I call VEnv, virtual environment. So now let's understand how a program is written. So if I just put a dummy icon here to represent the program, there is one that looks like a script, kind of this. Think about this is your code, okay? This is your code, and I just call it say program, and there must be a way to kind of change the direction. I don't know, where is it now? Okay, think of that is your program. This is your code, okay? This code is written in this IDE, the Integrated Development Environment, and the program is written in a programming language, a high-level programming language. It could be C++, it could be Python, Java, whatever. And the problem is this program cannot run without translating it into the machine's language. That's the job of the compiler. So therefore, the IDE and the compiler, they should know each other, where a compiler is and where the library is. So, sorry, the IDE is. So the IDE talks to the compiler saying, hey, I have this program, please compile it for me. Now, as I said, to compile a program, you must have the program first, and the program might need some specialized library set. And this comes from this VEnv thing. Okay. So let me just add this one here. So the VEnv will be kind of connected with the program, and the program will run in the IDE, and the IDE will tell the compiler, hey, I want to compile this. And after the compilation process, the program becomes something which is which a machine understands. Now, once you do that, you successfully run the code. Okay. Then, once the code runs successfully, you need to tell this version control system, hey, I have a updated version of the code. So anybody who's using your code would just point to this version control system, from which it will just get the updated version. Okay. So therefore, the IDE needs to also know where is this version control system. Okay. Now you give me a feedback. Is this clear? Any question from this diagram? What is? Yeah. Mm-hmm.
If anyone has a question, you can put that in the chat. So you say that the ID is where we write our code.
Yes.
And the code is what you call in a program.
Mm-hmm.
And so when we write a code, it sends the code to the compiler, which is the guy who would try to translate it into something that the computer will understand.
Yes.
So once it gets to the compiler,
Mm-hmm.
because our code may be written in a particular way, it may need some special tools, and those tools maybe you install them into a virtual environment, the VMs.
Mm-hmm.
So it goes there and picks those tools that you would need to make this code work properly.
Exactly.
And your version control is more like your GitHub is more like a place where you store your code online.
Exactly.
So that anytime you write the code, you just inform online that, hey, I've added a new line to the code, so
Mm-hmm.
keep it there.
Mm-hmm.
If a new person wants to make a copy of all the code I've written, this is the updated version. Is that what you're saying?
Exactly.
Okay. I think you're on the same page.
Right. So now we talked about the computer side, where you're doing these things on your system, on your machine. Now let's understand some more terms regarding the VCS, right?
Sorry, there's two more questions.
Yes.
One is about what's the debugger?
All right. So debugger will come across. It's an extension of this IDE. So there are certain things that we have in the IDE. Debugger is one of them. Sometimes when you have a long code and sometimes the code is not running, you are having some unexpected output from the code. Then what happens? You might want to see every single line, what happens in every single line of the code, right? So a program is essentially a sequence of instructions. So you give those instructions to the computer to do something. Now let's say there is some problem you have in one of the instruction which is causing the error. So bug is a problem that IDE cannot detect. So if you make a spelling mistake, for example, writing your code, the IDE will tell you, hey, this is a wrong spelling, right? But there is some kind of error called the bugs, which this IDE cannot detect. Okay, they are basically logical mistakes. So if you want to go through that code and see in each line what's happening, this is called debugging. Okay, so what a debugger does, it doesn't actually run the entire code in a single go. It runs line by line, so you can monitor what's happening in every single line. All right, so that's debugging.
So in effect, the debugger is just more like a tool that helps you to find errors in your code.
Exactly.
Maybe you're supposed to write the code in a particular way, you don't
Mm-hmm.
write it in that way.
Yep.
It catches that and tells you, hey, you made a mistake. There's another question. What's an interpreter?
All right, we'll
Is
talk.
it the same as a compiler?
No, no, it's not.
What later?
We'll talk about later. So let me just give you a quick glimpse about it. This thing, the general term of this is a translator. Okay, it translates a high level language to a low level language. Low level languages are those which the machine understands directly, like the binary code, assembly language. But this is very difficult for a human to understand. So what we write is not a low level language, but a high level language, which is maybe a C++ code or a Java code, Python code, whatever. Now, what happens? There are two ways this translator might work. The first approach is it takes the entire high level language and translates that into the low level language in a single go. Okay. And it is very much language dependent, I would say. C, C++, they are all, they work in this way. This is called compilation. You compile the entire high level language and you translate that into low level language. Now, in the domain of programming languages, there is another category of coding, which you call scripting. So a lot of time people misunderstand the term scripting. Not all coding are scripting. In a scripting language, what happens? Every single line has its own meaning. Okay. So to write a C program, for example, I don't know how many of you have done C or C++ codes. In a C program, just to run a simple print statement, hello world print statement, you have to run a lot of other things, right? Without them, that particular line won't work. But in other programming language, like there's one called Bash, which is used in Linux system. Python is one of them. These are not of that type. One single line of instruction would run like in its own totality. That single line has its own meaning. So when you write a program in that particular language, you don't write you are not explaining things in a single code, but you're explaining things by single lines. And this is called a script. So a script basically is a collection of statement and each line of the statement has its own meaning. Now, when we run this kind of programs, the scripting kind of program, then each line needs to be translated independently, right? This is called interpretation. So compiler takes the entire code, converts into a low level language in a single go, and then it will say if it cannot compile, okay, you have problems in this line. So it lists out all the lines where you have the problem. Whereas in the interpreter, it kind of interprets every single line separately. Now, if it finds an error in one of the line, the interpretation process will stop there and will say, hey, I have an error in this line. Now, if you fix that line, it will continue interpretation and maybe some other line will cause some other problem. So unlike compiler, it doesn't list out all the errors in a single go because it doesn't see the entire program in a single go. It sees the lines independently.
Okay, so from what you just said, well, they are more like doing the same thing, but they're doing it in different ways.
Yes.
So for a compiler, you're saying that first of all, it checks all the code
Mm-hmm.
and then it will detect where the errors are.
Exactly.
But with the scripting one, they use an interpreter. So basically, every line is a standalone command. And when you fix, if there's an error,
Mm-hmm.
you fix that line, and we could still have an error maybe on a different line later.
Exactly. You might think about it. Let's say you are a student and you are doing a coursework. Okay. Now, if your examiner uses a compilation process, it will ask you to do a problem and you solve the problem, give the solution, and the examiner will see the entire solution and give you, okay, you have problems in this line, this line, this line, and this line. Solve it. This is a compiler's job. An interpreter would start seeing the problem from the solution from the top. It finds the error and it stops there. It doesn't see the rest of the problem. It says, hey, you have a problem on this line, fix it. You fix it, you give it a updated copy, and it starts seeing from there. You see, that's the difference between compiler and interpreter.
I just want to take it back to examining way. You have a teacher and the teacher will must word everything and then give you a mark. And there's also this other stubborn student who will just pick your exercise and mark the first line and see that you made an error. Say, take your book and go and fix it and come back. You bring it back and then he'll go back to the next line. So, okay, there's another error. Go and fix it. So that's how an interpreter works. Fix it one after the other. But a compiler, once you submit, that's it.
Yeah.
It will check everything and tell you all the errors at one go. Okay.
All right. So that's the difference between compiler and interpreter. So therefore the general term is translator. Okay. So any more questions from this diagram? Okay. Now, to understand the right hand side of this diagram, the GitHub side, the VCS side, okay, there are three more terms you need to know. The first term, what we call pooling, right? So pooling means, for example, you have your code in GitHub, right? And you give that link to one of your colleague, one of your friend to examine, maybe your client. Now the client will first pool that code from GitHub. Okay. Now there are two terms which kind of confusing on the very first. If you are doing this for the very first time, if you are pulling that code from GitHub for the very first time, this is not called pulling. The first time it is called cloning. Okay, let me put the names here. So the first time when you do this is called cloning.
So when you say you're getting it for the first time, it means that you making a copy of that information that is online for the first time. So you don't have a
Yeah,
copy on your system.
yeah. So when you replicate that copy from the online side to the offline side for the very first time, that's called cloning. Now, once you clone it, so you have an offline copy of this, right? Now remember the term CI/CD, continuous integration and continuous deployment. Now, when you are adding stuff to this online version of your code, that is called integration. So you made some changes, you tested that thing on your local site, and then you made the update. This is updating the online version. Now, once you updated that, you might inform your client, say, I've got updated version of the code. So at that time, the client already has a copy of your code. He already cloned it. Now, when he's doing an update on his local side, he's also kind of replicating the code from the online to the offline side. But since he has a copy before, he already cloned it before, therefore it is not cloning anymore. This time is called a pooling. Okay. So cloning is the first time when you replicate, and pooling is the following time. So
Cloning is when you're doing it for the first time.
yeah,
Pooling is when you update in your copy. Is that what you're saying?
yes. Now similarly, this is the deployment part. So continuous deployment. So you don't have to send the entire software package. And the benefit of using this kind of version control tools, it kind of compares that what you have and what are the changes that is on top of that. It will only update the changes. So let's say your software is like 1 GB of size. Each time when you pull, you don't pull 1 GB of data. You only pull those elements which are updated. Make sense?
Yeah. So you're saying, let's say the first one, when I did the clone, I had maybe 80 MB.
Mm-hmm.
And then the next time I go there, I realize that it's now 100 MB. The new copy adds 100 MB. So I get the extra 20 MB.
Exactly.
So it will only find the ones that are missing, and then
Mm-hmm.
it sends them to me as updates.
Yeah.
So when I'm doing the pulling, it's saying, okay, give me the update.
Yes. So now you can understand why this version control system integration is so important. Because think about when you update your softwares in your apps, for example, you don't download the entire app. If you do that, then the customer won't be happy. For every single changes, he has to download the entire app, right? It only adds up to those updates which you made from your side. So when you make your update, that you have to tell the GitHub or the VCS that, hey, I'm making this update. Now there are two terms would come here. The first term is called push. They're just the opposite of pulling. So you're pushing your update to the VCS, right? The second thing is called commit. Now again, this is another confusing term. Think about, you have a program in your computer. So your ID has a copy of the program. Now you made some changes. Once you made the change, you compiled it or you interpret that, whatever, you ran that code and the code ran successfully. Okay. So now you know I have an updated copy. So what you do first, you tell your local system, hey, this change is good. Okay. And this is what we call commit. I haven't talked about pushing it to the VCS yet. You are saying
Talking about pushing.
not,
So
yeah,
you want us to tell the system that, hey, I believe that this copy I have now
yes,
is good.
exactly. So what we do here, you first commit means this change is good and you tell it to the local system. Once you do that, then you push that committed version to the version control system.
Okay.
So
So it's like in
yeah,
the company there is a post room.
mm-hmm,
So when you do a commit, you say that, can you send this to the post room
mm-hmm,
in
exactly.
the company? So when the postman comes, he picks that one from there. That will be a push, right?
That is a push.
Versus when you send it from your office
Mm-hmm,
to the post room in your company,
mm-hmm,
and you're waiting for the delivery guy to take it to the post office.
exactly,
So the delivery guy comes to your um, the post room, picks it up, and then sends it to the post office. You say you've done a push.
exactly. So these terms, I mean, this is one more term that we normally use is called send it to production. Okay. This is a term you will hear again and again in a software industry, send it to production. What does it mean? Let's say you are responsible for developing something, not necessarily a software, but anything. The moment you say I'm sending it to production, means this is going to the clients, is going to the consumers, right? And you don't want to send a buggy product to the client or the consumers. So first thing is you write the program, you test whether the program actually works. If it works, then you kind of commit, okay, this change is good. Once this is done, means now the code is ready for production. Now when you're sending it to the production, that's the push. So the committed version of the code is updated code first of all, and it has no bugs. And then you send it to the production, means it goes to the a public domain where this VCS lies. And your client has that link of that project, and then they will either clone it for the first time or they will pull it if they're updating. So you can think of an app in the App Store, right? Which is a committed and pushed version of a software. When you're installing the app, you're cloning it. And when you're updating the app, you're pulling it. So if there's no update available, you see that in App Store, it doesn't show you an update available there. So how does it know? It sees what copy of the code your system has and what copy of the code the version control system has. If there's a difference between these two, means you have outdated code. That means you need pooling, and that's the update process,
Okay.
right?
So you're saying that, for example, WhatsApp, assuming I'm asked to download WhatsApp
Mm-hmm.
for the first time, that's cloning.
Exactly.
And then let's say for some reason there will be a new update or a new feature,
Mm-hmm.
and after some time I realize that my phone has the new feature. That means I pulled it.
Exactly.
Okay, understood.
Okay. So now with this diagram, we understand that how a software development process works. right? But all these terms that we have used are now generic. Let me give you the actual terms. So for our case, the IDE is gonna be VS Code. VS Code is a IDE from Microsoft, is Visual Studio Code. Don't confuse that with Visual Studio. Visual Studio is a different software which is a licensed product, and it's a lot more powerful than VS Code, okay? But VS Code is just the IDE, okay? Normally when you download Visual Studio, it comes with compilers. IDE like VS Code doesn't come with compiler, so you have to have your compiler ready. Now the translator for us is basically an interpreter. I'll tell you why. Because Python is a scripting language, okay? Python, to run a Python script, you just run like a one-line statement, and each statements are executed separately. So to write a hello world program, for example, in Python is just like one-line command, print hello world. That's it. It doesn't need some extra things to be in the code to run that. Now this is Python 3.9 for us, the interpreter. So Python language has two life cycles, two parallel life cycles. You must have come across these two terms, Python 2 and Python 3. So when Python was developed initially, and after that it kind of got bifurcated into two different branches. One is the Python 2 life cycle, which is different than Python 3. The syntaxes are different, and the libraries are also some sort of different libraries for Python 2 and Python 3. It doesn't mean that Python 3 is better than Python 2. Most of the jobs which are done in a constrained devices, for example, you write a Python script that is running on a very low powered device. Python 3 is a heavy language, so you might not want to use that one. So in those cases, mainly in the IoT or embedded system kind of development, Python 2 is more preferred than Python 3. However, if you're dealing with heavy application like machine learning, data science, OpenCV, this kind of application, in that case, Python 3 is your choice. So Python 2 and Python 3 are two different life cycles, and each has their own benefits and demerits. But the version that we're going to use is Python 3, and there are many sub versions of Python 3. So Python 3.9 is the language we're going to use here, right? So Python 3 is here, and the VCS is GitHub. So let me just bold this one. So all the bold term are the specific term, and all the the regular terms, they are the generic term. Now the program in Python has an extension py. So if I use this, a test is my program name, it has to end with py. Okay, so any programming language has their own extension. For example, every C program has .c extension, C++ is CPP, Java is Java, Python is py. And the VN stuff we will see inside the Python interpreter. It comes by default. If you're using Windows, okay, it comes by default. Is anyone using Linux? Okay, so I'll give you one or two extra commands, because when you install Python in Linux, these couple of tools will not come by default. We need to install it separately. Now, one more thing I missed before explaining the next thing is, as we mentioned, the VM is basically a container, okay, which is isolated for every individual project, and this container contains a list of libraries. Now, how do you install those libraries? This is one more thing. So people who are coming from C or C++ background might find it a bit difficult to understand initially, because in C and C++ we don't have such concept of libraries, okay, by default. Some updated version of those language might have it, but natively they don't support this idea. In Java, we have something called packages, that is libraries equivalent to Python. In Python, it makes it much easier to add or remove libraries. Now, one thing that we'll find while being a developer in Python, that let's say you want to do something, so OpenCV, Open Computer Vision Library. This is a collection of codes which are used for computer visions. So to get that, all you have to do to tell Python that, hey, I want this library, and Python will go and find this on internet. There are some places called repository. It will go and find it from the internet and download it for you and load it on your virtual environment. Okay, now that tool that does this for you is called pip, Python package installer or something. I don't know the full form of pip. So pip is what we normally refer to as a package manager. So again, package manager is a generic term, and pip is the package manager for Python. Okay.
So I have one question. I have two questions. The
Yes.
first one, you say we're going to be using Python 3.9.
Mm-hmm.
Does it also mean that if somebody's having any other version for Python 3,
Mm-hmm.
they cannot use it for this particular session we run?
You can, but I want all of you to be in the same page. So use the updated version. If you're using something, don't use anything before Python 3.6, because after Python 3.6, a lot of changes that were introduced which are kind of best practices now. So therefore, if you're using some older version of Python, although I don't recommend for these sessions, but it should not be anything before Python 3.6.
So let's say if somebody has 3.6, 3.7, 3.8, 3.9,
Yeah,
it's fine.
it's fine.
But what about those who have something below 3.9?
I would say uninstall. Yeah, I'm going to show you. Uninstall your existing Python. I'll show you how to do that, and install the updated version of Python.
And somebody say 3.10. We said
3.10 is, yeah, that's fine. 3.10 is even updated.
3.10 is not stable, no?
It's not stable, and yeah, I'm going to talk about this again. When you download any programming language, any version of programming language, try to see if it is a stable version or not. Okay, it shows in the website. So again, non-stable means it is not ready for production. So it is somewhere in this commit stages now. They are actually developing the code on their side, but it is not meant for production. So you cannot rely on the code for writing a software which you will serve to your clients.
One thing I always tell people is that if there is the newest version, let's say for Python, let's say there's 3.10, I always advise people to download one
Exactly.
below
Exactly.
the newest version. So if there's 3.10, download
Mm-hmm.
3.9.
Mm-hmm. So there are two more terms before I get into the actual hands-on labs. One is called interoperability. That means the ability of a tool to interact with other tools. And another thing is called legacy support. That if you are using certain version,
Sorry,
yeah,
another question, I forgot that.
yeah.
You were mentioning something about a library.
Mm-hmm.
So you mentioned that a library is just like a pre-written code that people use to start.
Yes, yes, yes.
So in order for you to get a copy of that pre-written code of
Mm-hmm.
functionality, you need so basically telling Pip that can you find that particular library that somebody wrote or that particular code that
Mm-hmm.
somebody wrote and give me a copy of it so
Yes,
I can use it for whatever I want to use it for.
yes, exactly.
So Pip is basically like a
Pip is the package manager. So Pip is responsible for getting that library to your local environment. Okay. Um, as I mentioned in the previous languages, you have to actually go and find it by yourself and copy and pasting in some folders, which are a bit troublesome for large projects. So Pip actually makes it easier. Okay. I was explaining something regarding the interoperability and legacy support. So interoperability means if you write a program that might be written in a different version. Now the first property is this version should also support some existing versions. So it should interoperate with other versions. The second is legacy support. If you are using certain version like X, it should support versions which came before it. So for Python 3.6 is kind of a boundary. Okay, any Python distribution until now, it supports all the codes until Python 3.6. If you go beyond 3.6, then Python would not take responsibility to have a legacy support with those codes. Okay, so if you are using Python 3.9, it will compile anything which is written in Python 3.6 or after Python 3.6, but not before that. Make sense? Okay, so I think now this is clear. All the the schematic is clear. All the terms and what we the names of the
So
packages. Yes.
maybe if from what you discussed earlier,
Mm-hmm.
if I summarize what you have on
Yeah,
screen,
sure, sure, sure.
you want to clarify that more. So you're saying we started from, if we want to write code, we write code. So we need a software, which is the IDE, integrated development environment. And you're saying the one we're going to be installing is VS Code, right?
Yes.
So we'll be writing our code in VS Code, and when we run it, it will be sent to the interpreter, and the
Mm-hmm.
interpreter is what we're going to install. After we install VS Code, where we write our code, we want to also install Python 3.9 so that any code we write in Python can be understood and translated for the instructions to take effect.
Exactly.
Now, you also mentioned that we need a version control system, so a place where we keep our code
Mm-hmm.
online somewhere. And you're saying that assuming we have the code sitting online, we have to do a clone, meaning we have the code written somewhere and then we're using our own code or something. Will first have to clone it.
Yes.
And once we write it or we make changes to it, we have to first of all commit it.
Mm-hmm.
So like send our new copy to commit, meaning our post room.
Yeah.
And then once we get to our post room, we wait for the postman to come and pick it. That's a push.
You can think of a clone as an install, right?
Okay.
Pull as an update,
Mm-hmm.
and push as a publish.
Okay. And commit as what?
Commit means it is like within the production environment.
Okay. So you're keeping it in line for production.
Internal, let's say internal finalization, let's say.
Okay. Okay. Makes sense now. All right. I think we are on the same page.
Okay. So in this session, the target is I will set up this entire environment. At the end of the session, all of you will have your own GitHub repo. So repo is a kind of a short term of a repository. So when you build your codes, you put all of them on your repo, and it is very easy to share the repo with your interviewer or anybody you want to share with it. So um, you need to create a repository. I already have my repo, so I might need someone to share his or her screen. I will guide how to create the repo step by step, and since being already recorded and shared, so others can also follow me. Now, once we create the repository, then we'll integrate that repo with VS Code, and then I'm going to show you some basic step that you need to do for the very first time when you integrate them. And then after, you write your code and you push it to GitHub, and then you can see the updated versions are there. Okay.
Okay.
Right. So I have um, another machine here, which is a virtual machine, because I already have Python and all these things set up in my computer, so I'm not going to use that one. Let me start from scratch. So at the moment, how do you know if you have Python or not installed in your system? So if you go to your command prompt, um, you can just go to run and type cmd. Okay, it will open here. So if you think I'm doing a lot faster than your grip, then you might just interrupt me. Okay, so if you just type Python and press enter, if you see something happens like this, you get this prompt back. Okay, that means you already have Python installed, and it tells you what versions you have installed, like 3.7.3 in my case, which is a bit outdated at the moment. Now to exit from this prompt, if you're already in, just exit won't work. If you say exit with these two parentheses, okay, that means you're telling Python to exit from the interpreter. Okay, press enter and you're out. This other way of checking without getting into the prompt is if you just type Python and then space hyphen hyphen version, and it tells you what version of Python you have already installed in your system.
So when we type Python dash dash version,
Mm-hmm.
so Python space dash dash version, it
Yeah,
gives us the version, or it makes you know that what
yeah,
we have typed is the version.
Yeah, so if you have Python installed, it tells you which version you have. If you don't have Python, it will tell that, okay, I don't know what Python is, right? This is how you know if you have Python or not. Let me just increase the font size a bit so it is more clear. 28, I think is it good?
Yes.
Yeah, right. So now, because I already have Python, I want to uninstall the Python first and install a newer version. To uninstall Python in Windows, you need to go to Control Panel, or you can just search add or remove in your search bar, and you'll get this option called add or remove program, right? If you go there, you should find Python somewhere here. So Python 3.7 32-bit, this is the version I have, and just click uninstall to uninstall it. I think something also going on at the moment. Okay, give me just 1 minute. I had an install process running. I had to restart the system.
Okay.
And just take 1 minute to restart this.
So you're saying that if we want to check whether we have Python, we
Mm-hmm.
go to command prompt and then we type Python, and if we have it, it will go into the shell and then it will
Yeah.
exit the message. Otherwise, once you check it and you want to exit, you type exit with opening round bracket and closing round bracket.
Yes.
Then it exit there. Or you could just type
Python space version. Yeah. Okay. So yeah, my system is now restarted, and yes, of course, this is a dummy version. So I'm just using for the presentation purpose, not for actual production. If I now go to add or remove program, add or remove, it will take me to the control panel, and I'll find Python somewhere here, Python 3.7.3. Press uninstall, and it'll just uninstall the existing Python version. So if anyone has a Python installed which is not the latest version, please uninstall it, because I want all of you to be on the same page, right? Now, for those who are Linux user, let me just type the commands for you.
Okay, so there's one question.
Yeah.
Somebody said they have Python installed, but
Which version?
the command, but it didn't show. It looks like it's something to do environmental variable.
Yes. So in that case, you should actually uninstall the Python, because I think there's something called environment variable configuration, which should have been done automatically. If it is not there, your IDE won't be able to find Python, because the IDE actually finds through this. Yeah. Yeah. Yeah.
So what you could do is, Kofima, you have to uninstall it, and then you follow the process it's going to do now, how to install that version that you want to install.
Okay. So now Python is uninstalled in my case. I just click OK. For Linux users, for checking if you have Python, the command is same, Python space minus minus version. To uninstall this, if you are using Ubuntu, the command would be sudo apt minus y sudo apt auto remove python 3. This is your command to uninstall Python. If you are not a Ubuntu user, maybe a Red Hat user, then the command would be yum uninstall.
So you say the first command is for people using Ubuntu.
Yeah.
If
So,
they want to uninstall it.
yes.
And then the second one will be for those who are using maybe Red Hat.
RHEL, for example, Red Hat or CentOS, for example. For these users, you use this command sudo yum, and for Ubuntu users, you use the first command.
To uninstall.
Yeah.
I'm not sure anyone is using Red Hat or CentOS. I'm guessing that if someone is using Linux. So when you say Linux, which distribution are you using? The person said Kali Linux.
Kali is also Debian. Use the first one. Yeah.
Ubuntu, kind of. So use the first one to uninstall.
Okay. If you have any difficulties installing or uninstalling Python, I might share your screen. I might be able to debug from here. Okay. Okay. Now to install Python for the Ubuntu or the Linux user, I'm just typing the command here. And for the Windows user, you're gonna just follow me in a moment. So sudo apt-y install means you're telling your operating system to install a package. For us, the package would be Python 3. But as I yeah, install Python 3 means you're installing Python 3. But as I said, that there are other tools like pip and other thing vn, they don't come by default in Linux versions. So you need to also tell you need to install those things. So Python 3 pip is to install pip, and Python 3 venv is for venv. Okay, so this is the command to installing Python in Linux. Yeah, Ubuntu. Yeah, right. For Windows users, when you install Python, it comes as a package. It installs Python 3, Python 3 pip, Python 3 venv. Also, there's one more thing, idle 3. Okay, this is a editor, or this is an ID. I won't say ID, it's just an editor which lets you write Python script, okay, and run it from there. So, yes, but VS Code is much powerful, much more powerful than IDE. Yeah, this is a notepad exactly. Okay, so this is for the Linux users only, not for the Windows users. So let me show you how to get it. So you go to your browser, and if you just search Python install or Python download, it will take you to the official website of Python. Okay, so if you just go to the download Python option, okay, now Python 3.10 is the latest one. All right, when you see this version coming here, that means it's a stable version. Okay, so all right, we're gonna do Python 3.10, not 3.9. Right, so no, because that's a latest version. Yeah. Yeah. Mm-hmm. So if anything shows here in this button, maybe if you're seeing these videos after like 2-3 months from now, or maybe a year after that, you might find Python 3.11 here. So whatever you find here is the latest version. Okay, it supports the legacy version, it supports interoperability, so go for it. So click on this button and it'll ask you to download this exe file. Okay, okay, I am seeing one issue that I might face because this is a 32-bit operating system. This will not run this one. Let me just see if I can find a 32-bit version of this. So if you are using a 64-bit system, feel free to just download this one. But this machine is now 64-bit. That's why I need a 32-bit version. Go to my computer, okay, and right click and click on properties, and this will tell you it's a 32-bit system or 64-bit system here. Okay, but for the lab perspective, it doesn't make any difference for this. Let me just quickly find out a 32-bit version of this Python 3.10 32-bit. 32-bit packages. So if you just Google it, I can just copy and paste the link. Okay, I've put that on the chat. Let me go back to my other machine. 32-bit Windows version. Okay, download, and I'm sorry, not that one. This one, Windows installer. Okay, use this one, Windows installer 32-bit. Same, so the page is same, right? And you've got multiple options here. There's one which is embedded package is a zip file. Don't use that one. Use the Windows installer version. Yeah.
So you guys use the Windows installer version when you go on that website. For those who are using 32-bit, go and use the link we have provided in the chat.
Yeah. Now, once you download, if you click on this, it will start installing this. It might give you this security warning. Click on run. And I have another issue, which is my operating system is too old to do this.
You're using
Windows 7, because it's a virtual machine. So therefore, let me find out a version that actually works for this.
let me ask them, guys, is anyone using Windows 7 also? Because I'll be surprised if anyone is using Windows 7. Someone said they're using Windows 98. Are you joking? Just wait, I'm asking for you.
Yeah, let me just find out a version for me, because this is an older operating system, because I'm just using for the training purpose. That's why. Should be here somewhere.
If you're using Windows 98, I don't think you'll be able to do this.
Of course, you cannot run Chrome in Windows 98. So yeah,
That is not joking.
impossible. You cannot run Chrome in Windows 98.
We cannot even do what we're doing so far. So I'm really joking.
Okay, I'm falling back to 3.7. You are feel free to use 3.9 or 3.10. This won't make any difference in our programming part. I'm just using it because of my operating system is older.
So we could still use 3.9. So let's say
Yes.
those who have 3.9, you could still use 3.9.
Yeah.
Otherwise, those who are trying to install something, just install 3.9.
Come on. I think I made a big mistake by uninstalling that previous version of Python. Just a moment, guys. Let me just quickly find out a version that suits on my thing. Okay, if you have already installed it, let me do something then. If I'm having this,
Just give us a thumbs up if you've already installed it. How many of you have installed the Python, at least 3.9?
okay.
So guys, if you don't give us the feedback, we wouldn't know how many of you are struggling, because that's why we are here. Again, these videos will be. So you said you're struggling. You're struggling to.
Yeah, which part are you struggling with?
Iman, you said you're struggling. You're struggling to uninstall, or you're struggling to install. What do you mean by you're struggling? Just let me know in the chat. Okay, so it looks like we have 1, 2,
Mm-hmm.
3, 4, 5 people who said they've already installed it.
Okay.
Okay, which machine are you using? Are you using a Windows 10 or Windows?
We can do one thing. If that person can share his or her screen.
He's having Windows 10. Just go on their website and download a version from Python website. So python.org.
If you Google Python download, you'll find the link. Yeah.
Are you using 32-bit or 64? I think you should be fine. So just go to python.org and download the version. 3.10 or 3.9 is fine. That wouldn't take you too long to download. Any other person struggling, can you let us know in the chat? Otherwise, no, you could use 9 or 10. So it doesn't matter. At this stage, we try to get your systems working fine. So Beverly, yes, you could use 9 or 10, any of them.
Anything which is above Python 3.6 is good. For example, in my actual system, I'm using 3.7.6. Okay.
Yeah, that
Um,
will still work fine.
yeah. So the kind of thing we're gonna do in this course are not that advanced that would need specific version of Python. Okay, so 3.6 is the floor for the versions. Yeah.
Installed it.
Mm-hmm.
You were supposed to just download it, but some people installed it.
Mm-hmm.
Now, for those who installed it, I'm sure you were having issues because when they went to the system, they didn't put that in the interoperability or they didn't check it in the path. This is what you could do. Go to Windows, in the start button.
Let me just show them the thing.
Still add it to path. Where
If you search Python, if you have installed it, okay. So let's say I have got multiple version of Python. So you'll find just one in your case. Right click on that and click on this option, open file locations. Okay, click on this. This will take you to the place where this shortcut is placed. Now right click on that shortcut. If you can see my screen, Python 3.9 for example in this case.
for only those who said they went to command prompt and they didn't find it.
Yes. So if you go to right click on this and go to properties on that particular icon, you will find an option called open file location here. Okay, click on this. So first you go to start and search for Python, then write open file location, take you to this page. Right click on this icon, click on properties, and then click on this option open file location, and this will take you to this directory where the actual Python packages are placed. You need to copy this entire location, right? The directory structure, this thing. Copy this. Now if you go to your this my computer or this PC for Windows 7 or 10 user, let me just find where this option is. This PC, yeah, this one. Right click on any empty space, click on properties. Okay, wait a sec. They have changed in Windows 11. Environment variable maybe. Yeah,
For those using, if you just search environmental variables,
in start.
start menu, start environmental variables, and it should give you what you have found.
Okay, just go to start and search for en environment variable and all that. You'll find this option.
Those who are saying that when after installing, when they go to
Mm,
command prompt and they type Python, it doesn't show, but they are very sure that they installed Python.
yeah. Then click on this environment variable button on this window. Now there are two sections. In the second section, you will find path. Okay, click on that and click on edit. First click on path and then click on edit. Then click on new, and here you paste that what you copied. Okay, and once you paste it, press OK. I already have this one, so I'm not pasting it. So if you paste it and then click on OK, then come out of this, and now if you go to command prompt, it should work. Is anybody struggling with it?
No, some people are saying they've not installed it yet. Okay, so if you've not installed it yet, go to the installer, click on it, and then when you get to the space where it says that it brings a GUI, there will be something down there that will be add to path. Check that box to add to path, then you will not have this issue.
Yeah. The very last page where you see your installation is done, it says finished. There is one option that says add to path. Okay, click on that one.
Check that box so that you add it to path, so you will not have any issue. That's why some people are having issues.
Mm-hmm.
That's why we have to do it manually.
You can even take a screenshot of your thing and can just share on the chat so you can see what the issue is.
Anyone having any issues and it comes with a response or something, just give So can you give me a thumbs up, those who have installed it and those who haven't working, because we have to move on. Yeah, so you've done installing. Have you gone to command prompt to check? Okay, so those who said it's working, that's fine. Can we get at least 5 or 6 people saying it's working, and then we know what to do? If it's not working, just give us a screenshot of where you got stuck or what the error message is, and let's see.
Yeah.
I think we have more people saying it's working. So
Yeah. So if you go to command prompt and say Python space Python, space minus minus version, it should give you the version that you have installed. So if that is coming, that means your Python is installed already. Okay. All right. Shall we move on?
yes,
Okay. For the next class, I'm going to use a different machine. This is an older machine, so it's not supporting Python and all this stuff. I can see now. But for this class, just for this class, I'm going to use my existing setup. Let me show you step by step how to do that. So if I just recall this diagram again, so Python, the interpreter is installed already, right? The next thing is to install VS Code. So when you install Python from for the Windows, you install venv and pip together. Okay, you don't have to install them separately, but for Linux users, you have to do that entire command that install Python and pip and venv. So the next part is to first create an account in GitHub. The reason I'm doing this part first, because it is always better to have a habit that you first create a repo in GitHub and then you clone it and then you integrate that with VS Code. Okay, so we'll do VS Code for the very last step when we integrate all of them together, Python, GitHub, everything. Okay, so first you go to github.com. Let me share my screen. So if you go to GitHub, it will take you to this page. Okay, and I already have an account here, so I cannot sign up again because I don't have that many email IDs. So to sign up in GitHub, if you already have an account in GitHub, that's fine. Otherwise, you need to create an account in GitHub using your email ID. So if you click on sign up, it's a very simple process. You just need to put your email ID and just create an account. George, if you have any email ID, for example, which is not being used, you can just share your screen and show them the steps.
so you want me to?
Create a GitHub account.
Okay, so give me 1 second. Let me create one.
So should I just stop sharing and you share your screen?
Oh, when I'm creating it, yeah.
Yeah.
Okay, let's see whether I have the. I just want to confirm whether this account is
Mm-hmm.
being used.
Yeah, make sure your account you have the email synced, because GitHub will send you an email with a verification code to finish the sign up process. So make sure you can access the mailbox.
Okay. So I'm going to share my screen. Give me 1 second.
Okay.
Can you all see my screen now?
Yes.
So sign up, yeah.
Yeah.
Okay.
Yeah. Now put your email ID there.
All right. Guys, I don't want you to be sending me emails.
Mm-hmm.
Okay. So yes. So create the password.
And give a username.
Username. All right. Yes. Yeah.
Yep.
So start puzzle, yeah?
Yeah. I think
Select the
the
last one,
first one.
the first one, yeah?
Mm.
Okay, done.
Yeah. Second row, first column. Sorry, first, second column, first row. Yeah.
Second, are you going to
Yeah.
the
Yeah. Yeah. Second row. Yeah. Yep. Yep.
second or first column?
Yes. Yes.
Alright.
Now click on create.
In Ghana, when we say row, it means column.
Okay. Right. Let's transpose it then.
So you know when you get you saying row, the other part of the word is column.
Okay.
That's why we always use that. Okay, so
You
now
should get an yeah, should get an email. I don't think you should share that part.
oh yeah. Let me stop sharing. So
Yeah.
somebody can still pause the video when they see the video. I think it's just a one-time code. I'm guessing. Can I not just open the GitHub directly?
You can. You need to first finish the account creation.
Okay, so I'm going to share my screen. Yeah?
Yep.
So this is it. This is so you're saying this is the GitHub. This is
Yeah.
the
This is the page you should land on. Exactly. That's your page. So guys, if you finish that process, this is very simple. You just go to GitHub and click on sign up. It will first ask you your email address. You create a password and then a username. Username is not your email address. It's a name that you give. And if it is not unique, GitHub will tell you that name is not unique. So you just make up something, right? And then it gives you a puzzle. And once you solve that puzzle to prove you're not a robot, it will send an email to your account, and that email will contain a code, and you put that code to that GitHub sign up page, and then your thing will land up in this page. This is the page which is your profile, right? So give me a thumbs up if you have finished this process.
let me check 1 second. What's my password? That's funny. My password is password. Do you still want me to share my screen?
No. So once you finish your sign up process, right, and you have your password and your user ID, so this is my user ID, this is not my email, right? So then if you sign in, you would have a similar kind of view. You won't see anything which is showing on the left here because they're all my repositories. You won't see anything here, and you just see a page like this without these repositories.
Do you want me to share my screen one more time?
Yes, 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 sure.
So you'll be seeing that there's nothing here. So it means I don't have any code I'm storing online.
Mm-hmm.
Is that okay?
That's all right. That's perfect. Perfect. So guys, those who have just created your GitHub page should have the same page that George has now. It should show your profile icon and all these things, and the repository side, the left hand side part, should be empty. So let me share my screen again and let me show you. Um, so this part should be empty. The repository part should be empty, and we will populate this part throughout this course when let's do one by one all the programming exercises. Now, before I get into the first repo build and all this is your profile. Okay, this is your profile. So if I just click on this icon, profile icon, and click on the profile name, you see github.com slash your profile name. That is your URL. Now if you want to share that, you just copy this and put it to your maybe in your CV. So if someone wants to see what kind of programming you do, what are the projects you have taken so far, which are public by the way, you can just share this link and anyone can just get into this without signing in. So if I copy this,
Can also try them if their URLs have been chat so that we can
yes,
reference.
yes. So this is an online identity of yours. It is the github.com slash your username. So if I just copy this and I paste it here, let me just open in incognito so I don't use my username and password. Let me show you what happens. If I paste this, you see I can access all the details, right? But I'm not signed in at the moment. It is asking me to sign in or sign up. So I'm not signed in, but I can see all my public repositories. Of course, if you are not signed in, so you can only see the public repository. So these are the things that we'll create. Okay.
When you say public, you mean the
Mhm.
code that you click on and that you want people to be able to see?
Exactly. So if let's open one of them. Let's see this one. You will build all this kind of stuff when you will do the program exercises. Now they're all public information, so anyone can come and access this kind of stuff. Okay, and here these are the repository names. So don't get confused with this. If you share your link with somebody, they can access only the public information. So when you create repository, which you're going to do in a moment, it will ask you, should I keep it public or should I keep it as private? If you make it private, then this internet access, through your username won't show them the private repositories. Okay, to access them, you should have your username and password. Right? Any questions?
No, to confirm that what we hearing is what
Mhm.
you're saying. When we create the code and then we put it on GitHub, when we get to that, they'll prompt us to either select it to be public,
Mhm.
meaning we want people to be able to see it, or we want to select it as private, meaning we don't want people to be able to see it, the code.
Yes.
Okay.
Let me uninstall my VS Code so I can show you the installation process from scratch. Okay. So this part is done now. This right hand side part is done now. So we have installed the compiler, or the interpreter, the VN and package manager. GitHub sign up process is finished. Now we have to install VS Code and to link all of them together, the interpreter and the GitHub. Okay. So to do that, let me first uninstall my VS Code. Let me see where it is. Visual Studio Code. My Microsoft Visual Studio Code. I don't know how they put it on. Okay.
You're looking for VS Code.
Yes,
Yeah, that's it has that icon, the blue icon. I think it's under V. If you look for V, doesn't mean you don't have Visual Studio Code.
I have it. Of course, I have it.
Try Microsoft then.
Hmm.
Is it under Microsoft?
Yep, this is Microsoft Visual Studio Code. Okay, let me first uninstall this. It's a very tiny software and it's free.
Sometimes the people are asking for your profile. So they wanted a profile. I sent the one we just created. They said no, we want Saptash's profile. So I'll put that in the chat.
I will surely. I'll show. So now we have got our Visual Studio, sorry, GitHub repo, GitHub profile created. Now the steps are this. We need to have an editor, the IDE, right? And the IDE is VS Code. So first we'll install VS Code and then I'll link the interpreter and the GitHub together. Okay, right. So let me show you the steps. If you go to your browser and search for VS Code and press enter, the first link is from the Microsoft Visual Studio Code. So code.visualstudio.com, that's the URL. Just click on download and it'll tell you which distribution you want it for. For Linux users, don't do it now. I'll show you the command to do that. Okay, this is not a good approach to do Linux installation for VS Code. So for Linux users, wait for a minute. Let me download this one for Windows. So click download and it'll ask you to download this somewhere. I'm just putting it on desktop and saving it. That's the exe file. Meanwhile, it gets downloaded. Let me show you the command for the Linux users. For Linux user, use this command, apt-y install code. Okay. If you are using Ubuntu, for people who are using Kali, use this command. If you are using Ubuntu, the command is a bit different. For Ubuntu users, use use first of all sudo, and here also sudo snap install -y code space -- classic. That's the command for Ubuntu users. Okay, and this is the command for Kali users, for example. Okay, try this too. I'm copying these commands on the chat. Yes. Okay, so now I've got this file downloaded on my desktop. That's the exe file, and the setup is very simple. Just double click on it, it'll start installing. Accept the license agreement, click next, and just wait a sec. That's all right. Make sure the last option is turned on. Okay, the path, add to path option is turned on. Okay, and then if it is done, just make sure that launch Visual Studio Code is ticked and click on finish. So if everything is right, you'll see Visual Studio window like that. Don't need to worry about anything. We're not going to use anything of this, any one of this, just to make sure you have Visual Studio installed. Okay. For Linux users, after you install Visual Studio, go to your application menu and search for VS Code. You'll find the icon and run this. So give me a quick thumbs up if you have installed VS Code already.
And those who don't have a thumbs up on your phone or on your laptop, just hit done.
Yeah.
Because some people were
Okay, Alma says done. Okay. Perfect. All right. So next thing, I want all of you to follow me for the steps. We'll first create a repo in VS Code, in GitHub, and then we'll clone that on our local machine, and we'll open that through VS Code and write our first program. Okay.
so you create a repo, so it's like you're creating a folder.
I'll explain that. Okay, the steps are this. We'll first create a repo. So create a repo in GitHub, right? Next step is to download or clone the repo to our local system. Third, open the repo locally using VS Code. fourth, we'll create a virtual environment or VNF. Remember the VNF thing from the diagram? We'll create a VNF. Then we'll do a pip update. I'll tell you what pip update is. And step 7, we'll write hello world. Now, you might say it's an overkill. A lot of steps just to write hello world. Okay. Now, just to show you, it is not that big deal because this is a step that you'll be using as a developer like every day. This is kind of a standard practice while you start writing a software. You might start writing a Python code right away. I can show you now. If I go to my start menu and if I search for idle, which is a editor that comes with Python, right? And this will give me an editor like this. I can simply say print hello world. It will print hello world for me. But again, there is no point of learning a programming language if it is not useful to the industry standards, right? So what I'm trying to do now is to, yeah, 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 yeah. So there's a difference between a programmer and a software engineer. A programmer just writes a code, and a software engineer understands the entire architecture of a software, and it can fit to the production environment. So yeah, yes, exactly. So let's say you are a Python developer. I've seen like multiple YouTube videos are there. You just learn the language, but once you go for an interview, the company wants you to know not just the language. It's obviously you should know the programming language, but also some other stuff like using GitHub or using VNF, this stuff. So I want you to practice them from the day one, so it becomes your second nature. When you write a program, you do it in this way. The very first day when you are doing this, it might look a lot of steps, but once you understand the steps and you keep doing it on every single project, this will become very easy. Okay. So with that, let's start the first step, which is creating a repo. So a repo stands for repository. So repository is a place where you put your programs. So if you go to my profile, you'll find there's a tab called repository. You won't find that this value 11 in your case because it's a fresh account. And if you click that, it'll list a lot of existing repos. Okay. Obviously, this is not my professional profile. That's why I'm sharing this with you. Otherwise, there are a lot of other projects which are private, right? So this is I only do for teaching. This profile I only show for teaching. So yeah, I can share this link with you guys. To share the link, if you want to share your link with anybody, just go to this button, this icon where it shows your profile picture, and you click on this name of the profile, and it'll take you to this place. Now normally everybody knows their username. All the developer knows the username. So normally they just give this, nothing else. Because if you know this, if I just go to github.com and / this, that's my URL. I'm copying this for you and I'm putting it on the chat so you can also see this. Where is this? Here. Now the difference between what you will see and what I am showing you here is you won't see me signed in. You will see my profile from a viewer's perspective. It's just like if someone sees your Facebook account. There's a different view for a viewer and a different view for the user, right? So you don't see me signed in, you just see my profile. You can see all the repositories there, but you cannot make any changes on them. You can only read, of course, because if it is a public thing, you can just come in and delete my profiles. You cannot. So it is only read only. Okay. Now the first step is creating a repo. So if you go to repository, there's an option called new here. Okay. So this is where you create your new repository. If you click on new, so all of you, please follow me from these steps. Okay. So the way repositories work is this. The owner name is there, your user ID, and it is asking you to put a repository name, and this is mandatory. So use a name which is not used in your profile. Okay. So let me just put test repo. And if it shows this tick here, that means this name is not being used in anywhere of your profile. Make sense? Right. Now you might put some description. So it is optional. You might skip this. So this is a test repo for Python training. Make sense? And then we have this option to keep it public or private. I want all of you to make it public so we can see what your codes are. And if you keep it private, then it will not show up when you share your link to others. Okay?
So this is what you were referring to earlier on when you said you can make people see it or
Yeah.
keep it to yourself.
Yes. Yes. So it's like a privacy, thing that if you want everybody to see your thing, then just keep it public, otherwise private. Now there are certain other things, and I want to talk about this. The first one is a Readme file. Now, for any project, it is kind of unwritten rule that you create a Readme file. What a Readme file does is a manual. Okay, so when you publish your software, you want other people to know how to use that software or tell something about the software, and then you use this Readme file for that. Now, I will not get into Readme file in this session because the way Readme files are written, it uses a different language called Markdown, and along the course I'll talk about Markdown briefly, so you can write this file. It is not a text file, first of all. Okay, it's a Markdown file. So if you just click on this button, what it will do, it will just create a dummy Readme file for you with the name or the heading of the file with the name of the project. So for example, test repo is the name of the project or the repo. It will just say there is a Readme file for test repo and there is nothing inside it, but it will create a Readme file for you. And the Readme file shows up in the main page when you open that repo. The next thing is, I'm gonna just ignore this part for now, git ignore. The usage I will cover maybe in the 2 or 3 weeks after when you get to use with GitHub. The last thing is the license. Now, normally when you put a public code, it is not that public that anybody can copy your code and use it for their purpose. So you also need to have some sort of evidence that is this is your code, right? Now, normally there are a lot of other licenses that comes here that kind of gives a uniqueness to your code that you can claim later that is your code. If you are putting something academic, if you are putting something like a manual of something or some notes or something like that, the usual practice is to go for the MIT license for those kind of information. If you are doing a software development, you're putting codes or something like that, then the two major licenses are Apache license 2.0 or GNU license 3.0. Okay, I normally prefer the GNU license for any code that I put, so that if somebody copies your code and didn't give you credit, you might claim that somebody has done plagiarism with your code without giving you credit. So this is where I always recommend, if you're putting a public repo, try to give a license, and it is recommended in the industry that any public repo should come with a license. Okay, any questions?
Can give them like 1 minute to check the boxes and also fill in.
Yeah, sure.
Fine. So guys, you going to do the same thing with creating a new repo, and then you're going to say test repo like you stand there, and then
You can use any name if what you like, but I'm just using test repo here.
so if you're done, you just put like a thumbs up or you say done. Let me know. If you're struggling, we'll just let us know. But you have like 2 minutes to do this.
Mhm.
Again, I just want to remind you that we overstretched the session because some of you are struggling to install the software. But we'll try as much as possible to get to where
Someone is asking which GNU license, or GNU General Public License to 3.0, the first one that comes here.
your network. Okay. Yeah. So, like I was saying, we will get to a point where we do hello world and then we'll wrap up the session.
Mm-hmm.
But I'm just hoping that at least if you guys are able to set it up, make everything work, then next week we move, because now this is the environment we're making everything own way. Otherwise, next week we will come back to the same stage again, which we don't want to. Please try as much as possible to give us a feedback on how we can do it. Oh yeah, it will be posted on YouTube. But if you say video, I'm not sure whether it's going to be okay because there may be places where we'd want to edit. Otherwise, we just post it. Maybe we just post it after. I don't think we said anything strange.
No, I had to actually give it a look after we finish it.
Yes.
Yeah, before we put it into YouTube, and we don't want to have any copyright claims or anything like that. Yeah. Okay, so are we good with this? The first, this page. Sorry. Yeah. So the next step is just to click on this button, create repository, which will take this information and create a repo for you. Okay, so first of all, you tell the name of the repo, a short description of it, the type of the repo, public or private, add a readme file, and choose a license. Okay, that's the basic thing you need to create a repository. All right, so if everything is all right, just click on this create repository button, and this will take you to your repo. Now, if you can see, let me show you the actual URL that it builds. So github.com/your username/your repo name. So you don't have to actually go all the time to your profile to copy this. You can actually make it by yourself if you know what your repo name is and what your profile name is, right? And see what just happened here. There are two files that comes by default. One is license file and one is readme.md. The license file tells you which license are you using. So it's a GNU public license version 3, and the license specifications are all there. So you don't have to worry about that. And the second one is a readme file, which gives you this. Now I'll not get into the writing process into this file because it uses a different language. We will see in one of our session, in a future session, but not today. So these two things you have by default. Okay, now just give a thumbs up or just say done if you are in the same page. You should have a test repo created with these two files.
Yeah, it looks like a lot of them are on the same page.
Perfect. So now let us put something here. So in this diagram, right, in the VCS part, we have created a new repo. Okay, so let me just put a shape here. So we have made a repo here. So the VCS is a kind of a domain, right, where you host all your repositories. So here, for example, I made my, that's the GitHub part. Yeah, the VCS is a general term that we use. GitHub is the VCS that we are using for this one. So test repo is our repo name. Yeah. Now there's one more convention you need to follow, is that the way you type it. Okay, there are two conventions. One is the camel casing convention, where every word should start with a capital character. So if it is test repo, it could T and R are caps. This is one convention. The other one is underscores. So you can use test underscore repo. You cannot use space, right? You cannot tell test space repo. It has to be a single string. It has to be a single word. So you might isolate them with a camel casing like this, or the more like contemporary way of doing this is using underscore. Okay.
So where we need a space, we can use an underscore.
Yeah, because exactly. Think of it. If you would have just used space, what would have happened here? You would have end up with something like that, and the HTML or the browser won't understand that thing. So even if you make a space, GitHub actually I think put a hyphen or something to replace those spaces. Okay, it won't let you create a repo name which has a space in it. So this is the page where we have our repo created. Nothing is inside, and I'm going to link this to the to the IDE, the VS Code, and then we're going to run our first program, and we're going to sync it with VS Code. with the VS Code and GitHub. Now to do that, again start following me from here. This step is done, right? The first step is done, creating a repo. This is done. Now let's clone the repo to our local system. Now why am I doing in this way? I might give you a whole session on GitHub. It's a big topic. Just to kind of start this, when you clone a repo to your local system, it adds certain other files that tells your operating system or your IDE this is not just any folder. This is a folder which is synced with the GitHub. So you don't want to create those things manually. You can obviously do that, but no one does that. If you clone it, then what happens? This comes automatically. Now to clone this, you need one more tool, which is Git for Windows.
That's for those using Windows.
Yeah. For Linux users, you would be using this command, sudo apt-y install git. Okay. This is for the Linux users, sudo apt-y install git. And for Windows user, just go to this Git for Windows and you will get into this page. Okay. And download. Yeah. So SCM stands for source code management, which is similar to version control system, the same thing. Just install the 64 or 32 based on your operating system. I believe I already have it. Let me just check. Yes. So the same process, you click on the download Windows setup and run the setup and install it. Now those who are installing in Windows, let me tell you, it will give you a lot of options when you install this. Don't check or uncheck any of those. Just keep pressing next. Keep all the settings as default. Okay. Let me see if I can do it on this machine, so I can just guide you through this. Git for Windows, and I go to the first link. Download the 32-bit Windows setup. Okay, don't use the portable version. Use the setup version, the first one, 32 or 64 based on your system. Yeah, and once you install it, run this.
So someone is saying I have Git free and Git bash on my machine.
Yeah, that's fine. If you already have Git bash, then you don't need to worry. Right? So this setup would look like this, and just keep pressing next. Don't check or uncheck anything. Okay, keep all the settings as default. So I'm not doing any changes. I'm just pressing next. Whatever option it gives you, just click next. The last option will be install, and click on install. Yeah. Because this is not a session on Git, so I'm not getting into those options in this stage. You just keep it default. Alright, if everything is fine, it should give you this page. Just click on Git launch Git bash and please press finish, and you should have this command line prompt coming in. If that comes out, that means your installation was successful. Okay. Yeah, you should have this Git GUI or Git bash. Actually, we're gonna use the Git bash for our case, right? To do the integration. Okay, so maybe we add another step here. So 1.1, let's say, install Git. For the Linux user, you have just one line command, sudo apt-y install Git. This. Okay. All right. Now let me show you in the picture where this Git comes in. So as I said that this GitHub is an online entity, right? And your computer has this VS Code and all this stuff. So you see these arrows from your system to the GitHub and the arrows from the GitHub from your system. This thing, they are called transactions. Okay. In the technical term, they are called transactions. Now there's somebody who should be managing all this, right? And this is managed by that Git installation, that the Git package that we just installed. Okay. So if you can think about it, it would come somewhere in the middle. So the Git package will come in the middle. So it will going to be installed in your system, of course, but this is responsible for managing all this stuff, pushing and pulling all this stuff.
So you're saying the Git is more like the tool that you use to communicate with your GitHub?
Yeah.
Okay.
Right. So GitHub is the online entity. Git is the package that will let you do all this push and pull and clone and all these commands, and that is why it is installed in your system, right? So again, GitHub is here. You have a repo created, and now we need to tell our Windows system or Linux system, hey, kind of clone that repo. Okay. So to do the cloning, the process is this. For Linux user, for Windows user, same process. You go and click on this code button on your repo, and you see this part, right? HTTPS, whatever is written here. Click on this button, this double squarish button. If you click on this, it will say copied. This is a unique link of your repo. Now don't confuse this link with this link. This is a link which tells you that okay, this is where my repo is. This is for our understanding. But for computers to clone this repo, you don't gonna use that link, you're gonna use this link. And you find it where you go to your repo first. With that link, you go to your repo first, and then you click on code, and then it will show you another link here, and click on this this icon. Okay. So if you copy this, it copies on your clipboard. For Linux user, for Windows user, same thing. Now you need to go to a place where you want to dump this, right? So what I'm going to do, I'm going to go to my desktop, and I'm going to create a folder. Let me just create a folder here, and I call Git. This is a practice again in the software community, that this is not the first and the last repo you're going to be cloning. So all the clone that you're going to be doing should be residing into one folder, right? So the Git folder for me here in the desktop is where I'm going to clone every single project that I'm going to deal with. Okay.
So you're saying that you creating a folder,
Mm-hmm.
you're calling it Git, and then anytime we clone or we get a new code from online, we want
Yeah,
to store it in this folder.
exactly. Right. So now in this folder, you want to dump that code. To do that, for Linux users, if you create a folder and right click on that, it will show you something called open in terminal. For Windows also, it shows you this option, open in terminal. If you don't see this option, what you can do, press shift and keep pressing shift, right click on this, and you get an option called open PowerShell window here. Again, for Linux users, you get that option by default if you right click, open in terminal. For Windows users, because I have some changes on my Windows, so I'm seeing this option. For normal Windows user, if you press shift and keep pressing shift, if you right click, you get this option called open PowerShell window here. Okay, click on that option. It will open PowerShell for you. Okay, let me see if Git works here or not. Yeah, yeah.
So how many of you are at the same page?
If you just type Git, let me know if this kind of thing comes in your screen or not. If this comes, that means Git is working.
So 1 second. So when we go into the new folder we created,
Mm-hmm.
we press shift.
Yeah.
Those who don't know what shift is, on your keyboard, the one that has the top arrow key, it should be on top of control or CTRL.
That's the position of shift. Okay. So if you open PowerShell and if you type this command, now the command is same for Windows user and Linux user. Okay. Git clone and right click. If you right click, it pastes the URL. For Linux user, you might need to actually go and paste it with the command edit and all that, or Control Shift V for Linux users. Okay, so your command should look like this: git clone and the URL. Now you can relate to these commands, right? The clone is the command that we used here. Cloning means installing something, right? So because we are doing it the first time, that's why we are using cloning. If we already have this repo and we want to update that one, then it should be pooling. Okay?
Also, from what you taught us earlier, we're doing that step.
Yes.
So we're saying that Git, because that's the language,
Mm-hmm.
kind of
Git is the program that we just installed.
saying, okay, Git, we want you to clone
This repo.
this repo,
Mm-hmm.
which is the repo that we copied
Yeah.
earlier on. Okay.
And if I press enter, it will start doing the cloning into test repo, and it does something, and then you get a folder created. You see the folder test repo is created now, right? So this folder will have these two files, license and readme.md, the same file that you have on the online version. If you go to the online version, you see the same two files, readme and license, are there. So you just basically cloned it. Additionally, it also had a hidden file, a hidden folder, git.git. Okay, I'm not getting into this folder, but this is the folder which is responsible for telling the IDE that, hey, this is not just a folder. Okay, this is synced with something, with a Git repo. Okay, so this is why we are not just downloading that folder, we are cloning the folder. So cloning means you are installing this as a package. Make sense? Okay, so the setup is done. Let me go to that list. So clone the repo into our local system is done. So okay, then we gonna do this part. Open the repo locally using VS Code. Now there are two terms I'm gonna use very frequently from now on. Locally means what I'm doing on my system, on my computer, and remotely means what I'm doing on the web. Okay, so from now on, when I say remote, that means whatever I'm doing on the online version, and local means whatever I'm doing on my computer. Okay, right. So now you have got this folder created. The name,
One second.
yes.
It looks like someone didn't install Git. Check the spelling. Okay. So it's saying the term Git is not recognized. Did you open it in PowerShell?
No, no. Wait a second. If that is the case, means the installation was not correct. Okay. Do this. Whoever has this problem, go to your start menu and search for Git Bash. Okay. Do you see this option?
Did you see that option? Go to Windows. So the start menu. Okay. She saw that option.
Okay. Right. Go to that prompt, Git Bash. Go there. Tell me if it is opening.
Is it opening?
Yep. Hmm?
Yes.
Okay. Now go to that folder where you want to dump the file. So for example, for me, it is inside inside desktop and Git folder. Copy that location. Okay. If you click on your Windows search bar, just copy that location like this. Let me remove this so that I can show you what's going to happen. right? Now, if you go to your this git bash prompt, type the same command, git clone. Sorry, first you go to that folder, so cd, and paste the location of where you want to put that file. Wait a second, where am I? Just a moment, guys. Okay. Cd space desktop, and then my case it is git, so just put that location, and you will be in this location now. And then the same command, git clone, and you copy that URL from the GitHub page, which is this.
Can you show the step to copy the URL again, because some people are...
Yeah. So if you go to your repo, click on the code button, right? And from this pop-up, click on this button, this double squarish button. Click on this one. This will copy that whole thing. Now to paste it, normally in Windows, if you right click, it pastes automatically. So if I'm here, I'm just removing everything from there. So git clone, and if I just say right click paste, it will do the same thing. So since I already have this file, so it's not going to create a new folder for me. But if you don't have it, and if your git is not recognized by PowerShell, you can do it in this way.
So you're saying git is idempotent, yeah?
Yeah, exactly. Okay, so idempotent, I think you know the term, the meaning. If you already have the command, if you do it twice, it doesn't do that command again. It only sees the differences. Okay, so now we have the git cloned. If anyone has any problem at this stage, please put on the comment.
There's one issue. So someone is saying there's an error
What?
unable to access I think they're trying to...
Unable to access.
Can you show us the command or type the command you are trying to do and help? Because you're not giving us any information. You just type the error message.
Just a moment. Let me just go to this link and see. Okay, let me go to this link first. The link he shared, and to me, this link, it is not opening in my case, at least.
It's opening in mine. So
It is opening, right?
yes. It was created like 2 minutes ago.
So you just put this command I'm putting on the comment, git clone, and then paste that.
Maybe he was not putting the... Let me see.
Okay, this is your repo, right? Let me just do it on a screen. So this is your repo. Yeah, that's the same one. Eddie.
This is the repo,
Yeah, Eddie. So if you go to code and click on this copy option, right? This one, not that one. Okay, copy this link. Let me do it for you.
yeah? That's the same one I copied. So
Yeah.
same thing, yeah.
So let me go to that. Yeah, same directory where I have all my codes. It should be on desktop, the Git folder. Okay, just let me go there again. It's on my desktop, and it is the Git folder. And I open the same folder in my PowerShell. Let me clear the screen. Git clone, and I paste this. Test repo already exists. Okay, so I already have this one.
Oh yeah, that's the same one.
Okay, so I think you already have this on your folder, Eddie. That's why.
Because it's saying it's not resolved.
Okay, test one. Let me just get inside that folder and let me see.
Okay, 1 second, Eddie. Are you using the same machine to send us the message? Are you
Okay,
using the same
no, this
machine?
worked.
Maybe you probably don't have internet access.
Yeah, this worked. Exactly, this worked for me.
If
Because
he's using his phone to send us the message and he's doing it on a laptop or something, probably he doesn't have internet access at the time he tried it.
yes, of course, you must have internet to actually fetch it from the online one. Of course,
So you're
yes.
saying it cannot resolve the whole issue. I don't know.
Ah, yes, that's the internet issue. Right? Any more issues with this? Should I just say okay here on this step?
So he's asking where, how he's going to do that using Git Bash. So I'm sure you saved it on desktop. So you do CD desktop.
If you go to your Git Bash, right? Let me open again. Git Bash. So you have to first navigate to the folder where you want to kind of dump all your code. So in my case, it's desktop. So if I say cd desktop, and then inside desktop I have the folder called Git. So desktop Git, that is my location. I get inside this, and you see the name will change here, desktop Git, and the same command after that, which is Git Clone, followed by that link. It should work.
Do we answer your question, Eddie? So you do a CD desktop. You go in your CD desktop slash the folder which is Git, and then you go in there. You do Git Clone Repo.
Yeah,
Should be fine.
you must have the Git folder in your desktop to do this.
So yeah, we would have maybe 5 more minutes and then wrap up once everybody has been able to clone it. Can you give us a thumbs up because we have to do 1 or 2 more and make it not too difficult to do.
Yeah.
This is the most difficult part. Eddie, is it done? Yes, no. What's it saying, Eddie? Are you sure you have internet access on that device? Or are you sure you have Git?
What is the error you are having? Show me the error. I'll tell you what the issue is.
Error message. And are you sure that you have internet access on the device? Is it the same device you use? Okay, so can you give us the error message? Or we'll allow you to share your screen for 1 minute so that we can help you just for this
Yes,
part.
can you please share your screen? Yeah, that will be great. Yeah.
We'll do that.
Yeah, share your screen, please. Yeah. Go to your desktop. Yeah, go to the Git folder. Right. Now go to that address bar where the Git is written. Yes, copy this. Now go to start and search for Git Bash. CD. Yeah, that's all right. Yeah, CD desktop capital D. Yeah, just tab. It will fill it for you. Enter. Now CD Git capital Git Git. Enter. Git clone. Git space clone, and then paste that link. If you go to your online version, yes, paste it, right click, enter. All right, go to that repo again, test repo again. Yes, show me the screen. Yeah, see there's an option called download zip. Yeah, click on that. Yeah, just download that file to the Git folder. Start download. Yeah, now go to your download folder. Inside that compress, and you'll find this. unzip this. If you just say extract here, yeah, this will work. Now go and find that folder. It should be extracted somewhere. Yeah, test repo. Okay, now go back to the compress folder, right? Copy this, copy that folder, the test repo folder, yes. Go to your desktop, go to Git, paste it. Right, rename this file, rename this folder. No, rename the folder. And remove that hyphen main part. Just keep it test repo. That's it. Enter. Done. Okay, I know the issue what happened there, but I'm not going to discuss this now because it's a long discussion then. If you have the same problem, you have the fatal error resolving the host and all that, this is an alternative approach. Download the zip file and unzip where you want to unzip it. Okay.
I saw more than one issue there.
Yeah. All right. I'm sharing my screen again. Okay. So this part is done, right? All these parts are done. Now the next three parts are very simple. So we have got Git installed, we have cloned the repo, and now we're gonna do this VS Code part. Okay. Now to do this, you have to first go to that folder where you dumped your repository. For example, in my case, it is a test repo folder. I get inside it, I see this license and MD file, the Readme file. First, get into this folder, and then keep pressing Shift, right click, and click on Open PowerShell here. So you're opening that PowerShell into this folder, okay? And then type code space dot. Enter. Again, let me show you the command. You first get into the folder where you cloned your repo. In that folder, you right click, keep pressing Shift, and open PowerShell on that location. And inside PowerShell, you say code space dot. Now what this will do actually, it will open VS Code inside that directory. Now for the first timer, you might get a pop-up that's saying trusting the directory. Do you trust the directory? Press yes. You trust the directory. Okay. All good?
But when you do the dot, it's more like saying this particular
Yeah. So
folder.
exactly, dot means this in yeah,
VS Code
here.
take me to this particular folder.
Exactly. So code dot means open VS Code here. What I'm showing you in this process since I started, this is what we call the best practice. Okay. Now, I don't want you guys to become a programmer. You go and join a company and you behave like a naive. So when you do this, the company knows that, all right, he's not just a coder, he is also a software engineer. Okay. He knows how things work. So this is the process. You first create a repo, you clone that repo locally, and then you get into that repo and you open VS Code on that repo. Okay. Are we good?
Can we get a thumbs up for at least a few people in this thing? Again, it also means that on your CV, you're not going to say just like title. You could say you know about
You learned software engineering through Python.
Yeah, so you know about Git, you know about version control, GitHub, and all that. That's how it works. This is something you will not get in YouTube videos because they only teach Python and that's it.
Are you good, guys?
Someone said no, please. Can you give us more information?
More info about what?
No, the person is saying no, please, and I'm asking her to give us, or no, him to give us more information. Why he's saying no?
Yeah, guys, when you say no, okay, also mention what error are you getting. Okay, so we don't have to like do it back and forth. So if you're saying no, say, okay, I've got this error. It will be easier for us to understand the error and guide you better.
So, Prince, can you give us what the message is or what instruction is? At least 1 minute. You're getting an error, but what's the error? Okay, Prince, can you hear us? Okay. Can you share your screen 1 minute? So, Prince, is it possible for you to allow him share his screen for 1 minute?
Yeah, yeah.
We want to wrap up. We're almost there. Guys, sorry for the delay, but that's how programming works. Sometimes you want to finish early and then something hits you hard, and that's also part of the game.
What is the error are you getting, Prince?
He said some red arrow.
Yeah, but what is the error? You don't specify error like that.
Can you read it out? At least give us something. Okay. Code. The term is not recognized as. So basically, he didn't add it to class. That's why.
Okay. In that case, go to your start menu and search for code. You will find VS Code. Open it, right? And then click on open this folder. Open folder, for example, in this way. And then search that folder where you dumped your code. So in my case, go to desktop, git, and select folder. Sorry, test repo and select folder. Okay, you'll see the same exact folder like the one I opened with this code dot.
Next time when you come in a bit early, I'll show you how to correct that. It's just not in path. They're not adding it to path. That's where the issue is.
That's why I showed you when I was installing VS Code that make sure that one is clicked.
All these days, write down all your error messages and then put them in our WhatsApp group. So we'll look at them, and then when we come in back, or maybe I'll give you a guide of how to solve it. Something. Otherwise, you keep being a bit late, whatever. But that's how you learn, guys. When you get into an issue, you find a way to solve it. Once you solve it, next time you can help someone. The reason why I know what you're going through is because you've done it before.
Let me tell you one more thing. All of you are part of this discussion. When you are trying to become a software engineer, you have to be objective driven, not time driven, right? So for example, all right, we planned this lecture for like a year, an hour for a 2 hour, but I am not finishing because the objective is not done. You must be patient. You must be adamant with your objective, not with the time. Okay, so make it a habit. Okay, um, let me just get this going. Let me open my VS Code stuff where I just left this. So if I go to that folder where I have my test thing is, inside the Git folder, we have this test repo, and I go to the PowerShell there, and I say code dot. If that is giving you an error, that means like this. That means you didn't actually add that one. I removed that. You didn't see that happening. So that's the error you are getting, I believe. It means you didn't add the path. Okay? Yeah. Yeah. Because I put comma here. Okay? Not dot. So if this is what you get, means Git is not installed. Sorry, the code is not added to your path. Okay? Alright. So if you have Git VS Code open, the next step is to link VS Code with GitHub. The process is this. Follow the steps. By pressing Command or Control, if you're using Windows or Mac, whatever, there is a backtick key. Backtick key is the one that is below the escape character. In your keyboard, there's a escape key on your top left, and just beneath that, there's a key called backtick. You see? Press Control and press that key together. If you press that, you will get this command terminal coming up. Okay. Now this is where you interact with VS Code using command line. Now this command prompt is basically the PowerShell command. Okay. So you first go to this part. Open this. Any problem regarding this? Opening this terminal? Guys, if you be a bit more responsive, it will be good for me, because we need to know if you are following.
Some people are saying no, please. Some people are saying no problem. So I'm guessing they mean no, they're not getting it. Can you?
If you are not getting anything there, you can try the single quote character. You also have a single quote character in your keyboard. So let me show you the virtual keyboard option. If I can just on screen, I think on screen keyboard. So this key, okay, this normally comes underneath the escape character. This key.
Yeah, mostly it should be under the escape.
Yeah.
Escape. You have that.
If it is not working, try this key, the single quote. It depends on your keyboard layout sometimes. So try both of them.
Some of them are using.
I'm using a UK keyboard, so yeah.
Some of them are using double quotes.
Not double quote, the single quote one. Yeah. All right. In case you are not getting it, then I would like you to just write down the commands to sync the Git with VS Code. For those who have done this already, please follow.
Is it
Yeah.
possible to put that command in the chat?
Yeah, I will. So if you have this, so open this terminal, there is no command. It's a key combination. Is control and backtick, or control or single quote. The next part is to synchronize Git Hub with VS Code. To do this, once you open this stuff, right? If you see this icon here, PowerShell, and there's an add icon and the drop down icon, click on the Git bash from there. Okay. For Linux users, you don't have to do this one. It is by default in the bash. So for Windows users only, go and click on this option, Git bash. Okay. Now, once you are in this prompt, the Git bash prompt, follow this command. Git space config space -- global space user dot name. Okay, and then you put your username. The username is, for my case, is Rishi CSE. Whatever your username is, just use that same username and put it here.
It looks like everybody is fine up to that way. So.
The next thing is your email address, the email address you use to sync with your account. So user.email, and for my case, this is, let me just go back to my account, which should be here somewhere.
If you say the terminal, opening the terminal is control and backtick.
Yeah, I actually forgot what email ID I used to open this account. Let me just see if I can find a setting. Oh, come on. No, just a moment. There must be a way to see my anyways, you guys know which account you use to open your GitHub, right? Just use that one. Meanwhile, I'll find my email, the one I used here.
Okay. So guys, you have to put in your email, the one you use for this account.
So the command is this: git config. I'm putting it on the chat. So git config.
This is when they want to link it, right?
Yeah, this is a first time job only.
Okay, just one.
Right, and the same thing for user.email, and put your email address. Normally it should be on the settings.
So they're supposed to put their username, not your username.
Not my username, of course not. Yes.
So guys, where it says Rishi, from the Rishi, you don't want to do that. You want to put your username. So you, then it will be followed by your username that you have for your account. Just paste the username.
Oh yeah, found my email address. Okay, so so what you're doing now, you're telling VS Code, hey, I'm gonna be using this particular account with this particular email address. So VS Code will do the authentication for you. So when you make any changes on your code, I'm going to write a hello world script in a moment. This is going to be reflected on the online version. Okay.
So one second, it doesn't ask you
It will.
the password
It will. It will.
once you log in.
Yeah, no, it will ask me.
It will ask you.
Yeah. It will not ask your password. It will do something else. I'll show you in a moment. Okay. So here we just told this is my user ID. This is my email ID. Okay. They're the same ID I used to make my repo. Now on the left, you can see here, there is this icon. Okay. This icon. This is where your files are stored. Okay. Now there is one called source code or source control, and this other called the test repo. The test repo is the folder where you have all your files. You can see that license and readme there are already there. What I'm going to do, I'm going to create a first program in Python. I call test.py.
So
Test.py,
basically, we adding one more file to
one
the
more file.
download
Yeah.
file.
And by just saying .py, I'm telling VS Code is a Python file. And I press enter. Now, once you do this, there's one more step before you write the first code in Python. Is, if you remember, the VN part. Where is my checklist? This part. Create a virtual environment. Okay, not virtual. Oops, virtual. Okay. Well, the command is this. Mm-hmm.
You did the second one for the email.
Yes.
So they're supposed to do the second one for the email.
Yes. So if you see the screen now, there are two commands. One is git, global username and global email. There are two of them. There are two different commands. One is user.name and one is user.email. Okay, let me just copy this again. Uh, Accept my email address.
Put that in the chat already.
Yeah. Okay. Perfect. All right. So now, okay, let me do one thing. Let me just keep the VN part for today. We'll do it maybe next week. I'll just show you the first part, which is the hello world part, and sync it with GitHub.
So basically now we've been able to connect the GitHub
Mm-hmm.
uh,
With the VS Code. Yeah. So if I type hello print, and within print, within double quotes, if I type hello world, first of all, tell me, is the font size good, or should I just use a bit?
not good.
Not good, right?
I have a wide screen, so it's fine.
Okay, let me change it. This thing should be somewhere in the settings.
Is it possible to just, if you, or you're not using the Ubuntu
No,
desktop?
there is a. They have actually changed the appearance. Okay, editor layout, I think. Appearance and. No, actually, I can't find the option where to change this thing. Preferences, exactly. Preferences, settings, and text editor, and text editor, font, and I change it to maybe 20. Okay, that's better. Print hello world. So this is the first code we have just written, a simple hello world code, and then to run this code, there's a play button if you see here. Okay, if you don't see this, press F5. So we ran this, and you see the hello world is printed here. If I change this hello everyone and I play this, it changes to hello everyone. Okay, now think about it. Maybe this is your like 1000 line software, 1000 line code software, and you tested it and you got your expected result. Now the step is you want to commit the change and push it to the repo, isn't it? If you remember that flowchart where we did on the somewhere here. So if you first commit this, that is the internal finalization, and then you push it to the GitHub repo.
Just a quick one, Prakash.
Yeah.
Can you demonstrate how to create a new file in your repo? Someone
Yes.
is asking a question.
The repo file will be created from VS Code. Yes. Because I haven't done this. I am just
No,
doing it locally.
sorry, like I'm saying, not on the repo, but I'm saying in
Lo
your local
in
machine.
VS Code. Okay.
Yeah.
So if you click on this icon, new file. So test repo is your folder, and there's a button like this one, new file. If you click on that, and if you say test2.py, test2 is your file name, and py is saying it's a Python file. Okay. And here, for example, I write print this is file 2. Okay. And I play this. I see the print here. This is file 2. Okay. All good.
Well, someone is saying you don't have, they got an error message, you don't have an extension to debug Python.
Okay.
That was the message.
That's the message. If you click on this button, for those who are getting this message, see there's a button called extension on your left here. If you click on this and you search for Python. So first you go and click on this extension button and click on Python. Click on the first option, Python. Okay, normally it install automatically. For some case, I think it's not installed in your system, so that's fine. If you just click on Python, and in my case it is showing uninstall because it's already installed. In your case, you would see install button. Click install. It will take like 20-30 seconds based on your internet speed to install this. And once you finish installing, you come back to your file and you'll get that play button, and it won't give you an error.
Does that help? Are you able to install it, Edmond? Sorry, I cannot see the name, so thing here. Is it, who is that? Okay, Edmond is fine. So what about the other person having the issue? So mine is installing. There's one more person. It's installing. Okay. So it looks like we're making progress. We have a few minutes to go, and then, guys, like I said, whatever we're doing here is part of the process. With programming or with software engineering, you don't expect stuff to just work because you think you have all the tools at hand. You have to learn how to fix stuff. That's what makes you an engineer. Okay.
All right.
Yep.
Okay. So now if you see on your right here, okay, you have these three icons, right? Now the first one is the PowerShell that comes by default. The second one is the Git one that we just opened. Okay. So this one will be responsible for any Git related commands like pushing and pulling, committing, all this stuff. And the third one is to see your output. Whenever I run your code, it will automatically comes with the third option and it will show you the output here. But if you want to navigate to some other options, you might choose like the second one for the Git. Okay. So my code is working at the moment. I have got two files, test and test2.py, which are not in my online version. If I go back to the online version, where is it? What the name I created? Test repo, I think, right? It's not here. So let me just sync it. To sync, the command sequence is this. Now listen, I haven't given,
I
yeah,
lost you a bit.
okay.
Did you show us the graphic?
I showed you the online version where,
No, I mean, is it possible to demonstrate that on the graphic,
oh yes.
the picture version, so that we
So
can see it?
here, okay. So for example, here, I have my code, right? The Python test.py is already here. And now I have to first commit the change. So I finalize that, okay, this is the code I wanted. That's the committed version. And once I do that, then I'm going to push that code to the GitHub, the second part, right? So I've done the cloning part. I'm not showing you pull in this particular session, but we'll show you in the next session maybe. So first we'll commit and then we'll do the push. Now for committing, once you do the commit stuff, you'll see there are like two commands involved and you have to do every time you commit any changes. For pushing, we are changing something on the repo, right? We are adding something on the repo. So that needs authentication. That needs the VS Code to know that who is doing this. If you don't have privilege to do that, you cannot. Now, so far, we haven't given the password to VS Code to make that changes, right? So this will happen for the first time only when you link VS Code with GitHub. It will ask you to link VS Code and GitHub. It will never ask you your password. If you logged in already on your browser, it should be doing automatically. But for that, you have to log in to the browser, your default browser with GitHub. And then if you go to VS Code and you start doing that process, it will ask you to link with GitHub and just say yes. It will never ask you for your password. Okay.
So it's maintaining that session, the same one.
Yes. So make sure your VS Code is logged in. Not this one. Where is it? I think I lost somewhere. Let me go and reopen this. I think it's logged in somewhere.
Yes, it was logged in.
Yeah, this one. This is the AD's repo. So I need to go back to my repo. Let me just log in quickly. Oh, sorry, this one. That's my one, isn't it? Yes. So I have to be logged into my account to do this sync. So now I'm going to VS Code, and where is VS Code? Here, and I'm saying firstly git add dot. This means I'm telling Git that I'm going to watch on every single file I have created on this folder. Okay, so this is the first command you do. That's the commit process I'm starting. Enter. It says nothing means everything is okay. Now if you would have just noticed it, it was U before and now it becomes A. It means now it is checking on all the files. Now I'm saying, alright, so I'm happy with the code, so I'm committing this. To commit this, the command is git commit.
So the ones that say A, those are the ones that are new.
The A means I'm telling Git that alright, these are the file I've changed, so keep a check on that. Let me show you something. Let me just create a new file quickly. I said test3.py and I'm putting nothing inside it. Okay, and the moment I put something like a print, let's say just hello for example, and I save it, you see it's U means is unchecked. Okay, now so now Git will not know about this file until I say git add dot. So now git add dot, and now it becomes A.
So once you add it, means that these are the ones that are checked.
Yes. So that means I'm actually telling Git when you're gonna push all the file, check on this one as well. Right? Now you say git commit, commit, git commit space -m, M for message. So when you commit something on the software, think about a software engineer's perspective. You have to kind of put a note what commit you did. Commit means you made some changes on the software. So you must know I made this change. And normally the way we write the commit statement is within the double quotes, and it should be from the subjective point of view. So it's like adds hello world. So the commit adds hello world. Okay, normally there is another best practice that commit statement has to be written in a subjective perspective. Adds something, removes something, okay, updates something. So this comment, add this, press enter. It says create node, 3 new files got added. Just see the first line, it says that 3 files changed. Okay, and now we are good to go. We are now going to push that to the online repo. So the command is git push, nothing else, just git push, and enter. Okay. If you have a pop-up, tell me. You should have.
Sometimes you want person had an error.
It's not an error. It's a pop-up. Should be. Yeah. What's error?
When the person did the git add dot,
Mm-hmm.
it's saying that it said wait now.
Are you using the git bash? Make sure you're using the git bash. So you should be on this. Okay. By default, when you start, I showed this one. It starts from here, but you need to move to the git bash. To go to git bash, you use this drop down and click on git bash. It will open a window like this, these colorful ones. What's the error, by the way? Not a git repository. It didn't clone your git on that particular folder.
It was the same person that we had to do
The zip one, right? Okay. Just for you who has this error, let it just pause at that place. Okay, we'll sort it out maybe within this week if it's possible, George, because I know what happened there, so that's why.
Edmond. sure that you keep me in mind. Then when you send the messages this week, or even now, you could send a message onto the chat. I mean, on WhatsApp, or if you find my number on WhatsApp, send me a direct message.
For the rest, you should have a pop-up in your browser saying allow this access. Just press yes or allow. It is not showing me because I think my session is already saved, that's why. Otherwise it just should have opened my browser saying that someone wants to access your account. Are you approving this? Okay, this will never ask you your password. You just approve that settings and it will do its job. I'll show you what just happened now.
So someone is saying there's no response after typing git push.
Are you not getting anything like this? You check your browser, it should come on your browser.
You have a pop-up or something
Hmm.
in the browser, so online. Okay, it has.
Yeah, just approve it. So what just happening, because you,
Same thing, I also didn't get the pop-up.
yeah, check your browser.
Check
It,
your browser. It has to be in your browser. Go to your browser also.
Sometimes it comes as a Windows pop-up, sometimes it comes in the browser. It really depends on the operating system. So it basically does what? Your browser knows your password because you logged in already. Now the browser tells that to the GitHub application, this is the password, so now you can make a change. You don't have to remember the password for this.
One is saying authorize git to create a
Yes, 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 yes. That's the thing. So this is why we install the Git application. Now you can get it, right? This Git application we install to do all these things automated. Otherwise we have to do it manually. Okay. So that's the reason we have this Git application.
the username and then the email. You were speaking to Git to do that transaction.
Exactly. That's why I was using Git, that other commands, that Git config add, Git config add, Git add. So I'm telling this to Git to manage the rest of the stuff. So I don't have to do it manually. All right. Now, once you have done that approval and you do the push thing like this, now if you go back to your repo and refresh this page, now you see test2, test3. These files are here. And if I go to one of the files, it's test.py, I see the code print hello world, hello everyone. Okay, that's from my side, guys. Now you tell me if you have any questions, if you have any issues. That's the session for today.
Sorry, 1 second.
Mm-hmm.
Okay. So yes, I was starting with explaining so that you give you more information about that. So she'll be sending me a screenshot on it.
Can you guys see your codes in your online repo?
So can you guys confirm that for those who were able to follow the process, were you able to find the information that you just created with the new tab, the UI? Are you seeing it on GitHub? So someone is asking, can you please repeat the step to sync?
Yeah,
Say to sync, what do you mean?
I,
Sync
I,
by
I, I get the question. I get the question.
okay.
I'm typing the commands here. So all you have to do, you first go to the VS Code editor first, right? Like this. And then the default terminal will be this PowerShell one. We are not going to use this one. For Linux users, they will only use their default terminal. But for the Windows user, will not use this one. They will go to this drop down menu and click on the git bash option and you will get this prompt, the colorful one. Okay. In that prompt, you type these commands. So you first type git config -- global user.name and then give your username. Okay. So ABCD, I'm just typing That's your username. The next is your email address. So git config -- global user dot email, and then your email address 6yz. Okay, it should be the same email address using which you opened your account, and that's the account name. After that, this is the first step, and this is the step you do for once, for the first time only. Okay, once your repo is synced with VS Code, no matter how many clones you make and no matter how many codes you write, you don't need these steps. The next step is once you create your files and everything is sorted, then git add dot, that's the first command. So this is, I'm just typing, this is for once and this is for all time. So anytime you make any changes, this is the second part, the synchronization part, and anytime you make any changes, you have to do this following commands: git add dot, then git commit -m, and within double quotes you put your message, what you want to, what, yeah, the m means you are telling git commit and with this message. There's another extension of that. If you just space and put any other thing, like it's called the description side. So if you want to add more to the message, so the first type is the heading, actually, that it adds something. But sometimes when you do development in large scale software, that small heading is not enough, so you might put a description with it. So this, yeah, so this is an optional part. This second part is optional, but the first part is mandatory. Okay, and then after you say git push, and that's it. Now for the very first time when you put this command git push, it will take you to the browser to authenticate your VS Code with the GitHub account, because you are trying to change something on the repo. Once this is done, then this is also a one-time step. Okay, that part. And then in the following time, like me, when I put git push, it just does this job for me. Okay, that's the synchronization part. Did I answer your question?
I believe so. Yeah, you did. So yeah, Evans, can you just give us a yes or a thumbs up?
Okay.
It's fine. Yeah.
All right. So guys, this was the first session, and it's a hectic one, I know, but you need to, get used to with this. When you are doing it the first time, it looks a lot of steps, but when you keep doing this for every single project, this would be kind of your second nature. So now we have set up the environment, the developer environment. The only step I left for this session is to create the virtual environment, which I'm going to show you in the next session. So in the next session, we'll start with that step, creating a venv virtual environment, and then we'll start writing our codes. And for every single session, what I want you to do is whatever you do, whatever you learn, whatever you code in your repo, please commit it, so you can also track your progress and we can also see what code you have written. So if you have an issue with any code, you can just share your repo with us and I can simply go and check that code. I can clone into my system and run from my side. This would be much more easier. But for that, we needed to create all this environment, the sync with the cloud, everything that we have done successfully. So I hope you enjoyed, and if you have any question, I've just got 5 minutes to wrap up. You can put it on the chat.
Any questions, guys? It only gets easier, guys, because with programming, yes, there's a curve. So the learning curve, especially when you're learning something a new technology, at the beginning it's a bit difficult, but once you get one project or maybe one example from it, then the next time conceptually you'll be up there, so you know what you're looking for. You can even Google it and then you find the information. Don't say you've done it today, so you're okay. Keep practicing. We have to keep practicing. And make sure you're coming back next week, guys. You're not doing this for me. I said this last week. You're doing it for yourself. This is an opportunity for you to change something about you. It can be monetary, it can even be your status, how people perceive you in society. It's for you. Do it for yourself. That's just a few more sessions, and then you can call yourself maybe software engineers in the making or junior engineers. We'll give you an opportunity, as I mentioned, to get some kind of internship with us. But it depends on what you're bringing on board. We've given everybody a thing, so no one will say I have an advantage over the other. At least the minimum we'll look out for will be someone who can do some of the basic stuff we're talking about now, and that's it. At the end of the day, you guys will be able to work on simple projects in machine learning. Now, anything we're doing here can go into your CV. So like things like version control, using Git and GitHub, VS Code, you can start putting them on the CV. Later on, we'll show you how to maybe structure a CV. And trust me, you're in safe hands with Subtashi. I'll always be here to ask that silly questions that you don't want to ask. I'll ask them because you need all these things. All right. Or someone is saying, "Thank God I saw this course early and it's free." Yes, it's free, but it's not free because Subtashi is sacrificing a lot of time. That's a lot of time. You don't even understand what I'm saying. Apart from that, you guys are also sacrificing your time. So it's not free. Assuming you put in maybe 20 CVs every day in a container. Check how many sessions you'll be running and then see how much you owe yourself. So it's not free, guys. Okay. So we'll wrap up here and then